Okay, so good afternoon, everyone. Today we are going to start the week 4 live session. So I guess only uh, I need not wait for the people to join. Let's straight away jump into the questions that we are going to solve today. Okay. So today it will be mostly covering very elementary level questions, which was there asked in the previous 4 to 5 years. So the first question will be going like this. Let me share my screen. First questions will be on signals and systems. Okay. Okay. So the the input output relationship of a causal stable LTI system. What does causal stable LTI system means? It means that causal means if you are taking Z transform, or causal means the impulse response will be equal to 0 for n is less than 0. This means the output should not depend on the previous input samples. If y of n is the output which we are considering, then it should depend on xn and the future inputs of xn. No, sorry. Causal means y of n depends on present okay, present and past input samples. If y of n depends on present and future input samples, that means non-causal, right? Present and past input samples. That's what causal system means. What is stable system? Stable is nothing but when you summation over, since h of n is a discrete input, discrete impulse response, we'll be using the summation sign. Otherwise, we need to use the integral sign if it is in the continuous domain. If you are finding the energy below the curve or of the impulse response, it should be finite. That is what is stability means. So they have given an input output relationship. They have told that h of n, when you add from 0 to infinity time samples, the output will be 2. They are asking what is the relationship between alpha, alpha and beta. So this is what the question means. Now it's your turn, guys. You need to try solving this. The thing is, you try finding out the Fourier transform or Z transform for this expression, and try using some modifications you need to do here by applying omega is equal to 0 and all. You try solving this. Just try grasping the idea this question, what the answer should be. I'll solve it in 2 to 3 minutes. Just I've told you what is the meaning of the question. Try solving it and get the answers. Put it in the chat box. One way which you can do is see, this is nothing but h is n is equal to minus infinity to infinity h of n into u of n, right? So try thinking even a step ahead for the hint which I have given, or you can also think about some other way such that this condition can be used. Okay. Okay. You can also I guess you would have thought of an idea. Is there anyone who answered this? Yes. Good. Prabhat Hari Prasad has told the answer is 8. Let's quickly solve and find what is the answer for this question. Okay. So we have y of n is equal to alpha y of n minus 1 plus beta y x of n. So when you take z transform on both sides, you can also take Fourier transform, but let's go on with z transform. So alpha into z inverse by time shifting property, y of z plus beta x of z. So when you do this, you'll be getting a transfer function of h of z is equal to beta by 1 minus alpha z power minus. No, z power minus 1. Right? So this is what you will be getting. See, the impulse response is expressed as h of z, which is equal to, going from k is equal to minus infinity to infinity h of n z power minus h of k z power minus k, which is also can be written as k to infinity, k equal to 0 to infinity h of k z power minus k. So now put z is equal to 1. If you are taking Fourier transform, then you need to apply omega is equal to 0. So what you'll be getting is h of z is equal to sigma k equal to 0 to infinity h of k. Sorry, h of 1. So we have that this information, whatever which is given here, we can clearly see from the condition that is given in the question. So this should be 2. So that means substitute z is equal to 1 in the first equation, beta by 1 minus alpha, which is equal to 2. So what you will be getting? Beta by 2 is equal to 1 minus alpha. So alpha is equal to 1 minus beta by 2. The option is A. And both of the students are told the option is A. Is it clear with everyone? Okay. I guess it's clear with everyone. Okay. So I'll move on to the next question. Okay. So this is the question. Consider an FM signal f of t is equal to cos 2 pi fct plus beta 1 sin 2 pi f1t plus beta 2 sin 2 pi f2t. The maximum deviation of the instantaneous frequency from the carrier frequency fc is. So this is based on a communication subject. Try solving this. They have given an expression for FM signal. They are asking what is the maximum deviation of the instantaneous frequency f. Instantaneous frequency is nothing but fi, right? This is a form where you have two or more message signals which are sent. Usually, you would have studied using like uh, single carrier modulation. So this is a multi-carrier modulation. So you have modulation indexes of beta 1 and beta 2, and we need to find out what is the expression for the instantaneous frequency. So we need to compute what is the instantaneous frequency formula. So what is it? If anyone, one, Prashot says it's one. What about the others? Okay, let me solve the question. It's very easy only. Okay. So let me know, Hari Prasad, what's the answer? What about the others? Neetu, Bunty. See, the expression for the instantaneous frequency is nothing but the rate of change of phase. Frequency Fi of t is nothing but d theta I of t by dt. So if you find a phase change in any frequency modulation output, this instantaneous frequency is nothing but the rate of change of the rate of change of the phase. Okay, so we are given an FM signal cos of 2 pi fct plus beta 1 sine 2 pi f1t plus beta 2 sine 2 pi f2t. Okay, so here The carrier frequency is FC. What we have is we have the theta. Usually the FM signal will be of the form AC cos theta I of t. So here, if you compare theta I of t with the both the f of t expressions, you have theta I of t to be fct plus beta 1 sine 2 pi f1 t plus beta 2 sine 2 pi f2 t. So now, if you differentiate the instantaneous phase of the above signal, you will be getting Fi of t. So which will is equal to, sorry, here since theta I is in the radian frequency, we need to divide it by 2 pi. So this is the frequency f domain, then we need not do this. Since it is in the domain of radian, always the phase will be the domain of radians. So fc plus beta 1 2, like 2 pi and all will get cancelled. So f1 cos 2 pi f1 t plus beta 2 f2 cos 2 pi f2 t. So this is what is the usually the instantaneous frequency fi of t is equal to fc plus del f. Del f is nothing but the frequency deviation. Fc is the carrier frequency. So instantaneous frequency is measuring how much fluctuating the signal is in compared to the carrier frequency. So they are asking maximum of del f. That's what the question is. Maximum frequency. What is it? Maximum deviation of the instantaneous frequency from the carrier signal. So you can write it as fi of t minus fc. The maximum deviation is nothing but maximizing this. So you need to maximize the RHS also. So maximizing RHS, we know that we need to maximize beta 1 f1 cos 2 pi f1 t plus beta 2 f2 cos 2 pi f2 t. So when you maximize this, you know that cos value, maximum value is 1 and cos value is 1. So final answer what we will be getting is beta 1 to f1 to beta 2 plus beta 2 into f2. So the idea is good. Okay. So 100% now is it clear? What about the others? The rest of you guys? Shall I get some acknowledgement from you guys so that I can proceed on to the next question? If not, okay. Thank you. Okay. Um, I guess rest all questions I solved. Okay, let's go into the. Okay, this is a control system question. So the open loop transfer function of a DC motor is given by, this is the output of the DC motor and VA of S is the input of the DC motor. The open loop transfer function is given as 10 by 1 plus 10s. When connected in feedback as shown below, the approximate value of Ka that will reduce the time constant of the closed loop system by 100 times as compared to the open loop system is. So we need to find out what is the value of Ka such that the value of time constant of the closed loop system is 100 times as compared to the open loop system. This is one of the gate questions on control systems. I guess 2013 gate. try solving this question. Okay. Has anyone got the answer for this question? Okay. So that okay. So let me solve this question. Anyone has got any answers for this? Okay. So one of the important concept of the time constant is, okay. So usually in control systems, if they have given a system an open loop transfer function or a closed loop transfer function, if they are of the form, usually open loop transfer functions OLTF, if you are finding out time constant or close to it for any transfer functions, you can compute the time constant of system. Usually it will have a form. So that form is like this: 1 plus is 2, goes on up to, and divided by s bar n, 1 plus is ta into 1 plus is tb into. So this is equal to the open loop or closed loop transfer function. So if you have a transfer function which is of the form like this, where T1, T2, TA, TB, everything are time constant signals. so sorry, time constants of the signal, right? For example, if g of s is equal to k by s plus a, when you take the inverse transform, inverse Laplace transform, you'll be getting e power minus at u of t, right? So here the tau is equal to 1 by a. Why? Because we have the representation of any signal, any decaying signal to be e power minus t by, when you have, like if you would have seen in networks, you would have had the time constant of an RL circuit is L by R, or how do you compute those? So usually the form of the output will be e power minus t by tau, where tau is the time constant, right? Using this information, we can easily compute what is the time constant of the open loop transfer function that is given. So the tau 1 is equal to, you have some expressions, right? 10 by 1 plus 10 is. So compare this with the given expression. You have tau 1 is equal to 10. Am I right? Because the time constant is nothing but the coefficients of the S domain, S constant, right? So, okay. So, you guys know what is a time constant, right? So, a time constant is nothing but, if you are giving some input to the system h of t, and you're expecting an output y of t, right? So, suppose take the output to be like this: 1 power e power minus t into u of t. Some, if you would have given an input e power minus t to some specific impulse response, you have an output like this, y of t. This is the expression of the output. So this will reach the steady state. If you draw this, you will be getting something like this. So it will reach the steady state at some time t. So time constant is nothing but it is defined as the the time the signal has got to reach 0.632 times of the steady state value. So if you are equating this to 0.632, then whatever the time period which you are getting here, you need to represent by tau. So whatever time constant you are getting here, that is what means, so that is what it means when you will be finding out some t here. So that tau will be equal to some t which you are having, which you are getting from this above equation. So time constant is nothing but the time required for a signal to reach 0.632, or which is equal to e inverse of 1 by e times of the steady state value, right? So this is what is the time constant. So with this is the time constant for the OLTF, right? Until this is clear, okay. Let's see whether the answer is C. So the closed loop transfer function. Okay, so this is a negative feedback feedback, right? This is a negative feedback system. So negative feedback system is nothing but, you have You have an input R of S, feedback transfer function is H of S, G of S. You have an input, yeah, plus C of S. So when you have this kind of feedback, negative feedback system, the transfer function which is you are getting is G of S divided by 1 plus G of S into H of S. Right. So this is what is the transfer function. So when you're doing that, what you'll be getting is, so CLTF will be just, if it is a unity feedback system, then you can write it like this. When you calculate it, you will be getting 1 plus 10s plus 10. Okay. So you would have got, sorry, I left the KA. So 10 KA. This is what you would have got. So approaching the same approach, if you are trying to do, what you will be getting is the form should be as here. So 10 KA divided by, divide by 1 plus 10A, 1 plus 10 KA, you will be having 1 plus 10 S by 1 plus 10 KA. So now the time constant for this CLTF tau is equal to this expression, which is equal to 1 plus 1 by 10 plus Ka. So now you can, this is anyway, you can approximate it to be 1 by Ka also, because point 1 is negligible. 1 by point 1 will be even more negligible, so you can just, the impact can be reduced. So they have said that, yeah, so that will reduce the time constant of the closed loop system by 100 times as compared to that of the closed open loop transfer function. So tau, let's say, represent as tau CL, and this is as tau OL. So tau closed loop system is equal to tau OL by 100. So which is equal to 1 by Ka is equal to 10 by 100, which implies Ka is equal to 10. Is it clear? Yeah. As Prashant said, the answer is C. Is it clear with everyone how we are computing this? Okay. Okay. I think I have. So next question, I'll take it from controllability and observability. So the question goes like this: consider a state space model x1 dot x2 dot x3 dot is equal to minus 1 1 0 0 minus 1 0 0 0 minus 2 into x1 x2 x3 plus 0 4 0 u, and y is equal to 1 1 1 into x1 x2 x3. So they're asking, they have given a tabular column. Controllability, observability. So they are asking whether the system is controllable and observable. So the first option goes like both are controllable and the system is both controllable and observable. Next option goes like this. No, no, both uncontrollable and unobservable is the option. Try computing the system. What does the system? What is the system like? Controllable and observable, or so one of the take the note of the question. So this can be represented as x dot is equal to ax plus bu. So is equal to cx. Okay. So I'll describe what is controllability. So controllability is nothing but if you are having internal states of the system which are changing from one value to another in a finite time by a finite input, then we can say the system is controllable, right? Like whatever states of the system, like states means you would have it as in current voltage, anything like that. If they are changing from one value to another in a finite period by a finite input, then the system is said to be controllable. Okay. So what does observability means? So usually for controllability, they consider a controllability matrix 5C to be a power 0 b plus a1 into b. Sorry, a1 into b. This is a 2 cross 2 matrix. Or if it is a 3 cross 3 matrix, this is equal to a power 0 b, a power 1 b, a square b. 3 cross 3 matrix. So if the determinant of whatever matrix you are forming, which is equal to 0, then we say it is uncontrollable. If it is not equal to 0, then we say it's controllable. Similarly, for observability, if the internal states of the system can be evaluated from the output of the system of any time, then we can say the system is observable. So if you have some output of the system, then if you're trying to compute what are the internal states of the system, if it is possible, then we call the system to be observable. If not, it is not observable. So in order to check observability, we have 5 zeros equal to C transpose AC transpose when it is a 2 cross 2 matrix. Second order means like, and phi naught is equal to C transpose AC transpose A square C transpose if it is a third order system. Okay. So if you're finding the determinant of this, if it is equal to 0, then not observable. If phi naught is not equal to 0, it is observable. Okay. So in this question, you have A to be 1 3 cross 3 matrix, B to be a 0 cross 3. Anyway, it's a third order matrix. So you need to compute the matrix and then find the determinant of it. They are asking controllable. Okay. So first we'll see check for controllability. So 5C is equal to B. What is B? 040 B is 0, 4, 0. A, B, you should multiply A and B. If you're multiplying it, you get 4 minus 4, 0. And you can square this and multiply with B. If you're doing that, if you're squaring this particular matrix and multiplying it with B, you will be getting minus 8, 4, 0. So when you find, the determinant will be yielding to 0 because one full row is 0 here. So when 5c is 0, then what does it mean? It means the system is uncontrollable, which means the system is uncontrollable. Observability. If you're taking some matrix 5 naught and you are writing it like this: A transpose AC transpose A square C transpose. This is the third. Since the given system is third order, I'm writing it like this. C transpose means this is the C matrix, so transpose it. You'll be having 1, 1, 1. Now we need to multiply both the given A matrix with C. So when you multiply, what you'll be getting, minus 1 into plus 1 is 0. So you'll be getting an answer to be, one second. Uh, okay, so you'll be getting transpose. One second, I think I observability. Sorry, I missed the transpose here. Whole thing should be transpose, or you can write it as, usually this thing, you need not have these transposes. The whole transpose is there. Okay, this is the formula for observability matrix. Sorry, I made a mistake here. It's the whole transpose. Okay, so when you're doing that, you can write it as transpose or CAC A square C. So when you're doing that, C is a row matrix, right? So you can write it like this. Then multiply A matrix with C. You will be getting, what you'll be getting? 0, minus 1, minus 2. What you'll be getting? C minus A and C. Oh, okay, you need to. One second, I think I messed up the formula. I'm so. It should be CA and CA square. I'm sorry for this, because this won't satisfy the multiplication rule. This is 1 cross 3, so it should be CA. Then only we'll be getting a 1 cross 3 solution. So there should be CA. Yeah, I think now it should be fine. Yeah. So when you do this, you'll be getting an equation like an answer to be minus 102 minus 10 minus 2 because you need to multiply this row column wise and then 114. When you're calculating the determinant of this 5 node, it won't be equal to 0 because no row is 0 in the given matrix. Therefore, it can be found that this system is observable. Okay, the answer should be uncontrollable and observable. B. The answer should be B. So, whenever the question comes like this, you just need to formulate the formula, the representation like this, and then compute the determinant of the whole matrix. And if it is equal to 0, then it depends on the observability and controllability conditions. Okay, so yeah, we'll move on to the next question. Okay, I think I have a. Okay, so one more tricky questions which I want to solve before the session ends. So let me write out the question. The maximum value of theta until which the approximation sine theta, which can be approximated to theta, holds to within 10% error is A 10 degree, B 18 degree, C 15 degree, D 90 degree. So we say that usually when sine theta can also be approximated to theta. So the question goes like the maximum value of theta until which the approximation sine theta approximated to theta holds within 10% of the error is. So when you take sine 10 degree and only 10 degree, when you differentiate this, like when you find the error between these two, you need to have the error to be 10%. That's what the question means. Try solving this. Sorry. So usually we have this to be. We know that limit theta tends to 0 sine theta will be 0. Okay. For 10% error, when you have theta to be, just take one of the options from above. Okay, this is from trial and error only. You can just take out one of the options. 18 degree, convert it into the radian. 18 degree into pi by 180. So you will be getting 0.314. So compute the sine theta also, which is equal to sine 18, which is equal to 0.309. So how do you compute the percent error? Percent error is equal to the error divided by original value into 100%. Here, as far as here is considered, sine theta is the original value, theta is the approximated value. So when you find it 314 approximated minus observed divided by observed is equal to into 100% will give you some 0.49%. Similarly, for theta equal to 50 degree, theta equal to 50 degree, you will be having converted to radians 50 into pi by 180, which is equal to, you'll be getting 3.14 by I guess it will be coming around 0.873. When you're putting theta equal to 50 degree and finding out the original value, sine theta is equal to sine 50, which is equal to 0.77. So the percent error will be equal to 0.77 minus 0.873 divided by 0.873, which is equal to minus 12.25 degree. You need not worry about the minus sign, that's not an issue. So since this falls more than 10% error, this option is ruled out. So only for theta equal to, when you, as you can try it for A and D, you will also still find that it is more than 10% error. So the option is A, not A, sorry, it's B. Because for 18 degree, you will have the theta to be original value to be sine theta, which you will be getting this one value. Similarly, when you convert it to radians, you will be getting a particular value. When you find the error, you will be getting a value. So that's what, and if you're finding it, you find that it is less than 10%. That's what the question requires. So it goes like this. Any doubts in this question? Is it clear? Okay. Okay, then that's all for today. Or we can solve one more question on signals and systems again. A simple elementary question. So they have given a differential equation to be y dot of t plus 5t is equal to, sorry, 5y of t is equal to u of t. They told that the initial condition y of 0 is equal to 1. U of t is initial. They are asking what is y of t is equal to. It's a very easy question. Let's see who answers this first. Just take out the Laplace transform and do it.
Hello,
Yes.
no, ma'am. Ma'am, I asked about some question from 2020 gate.
2020.
Yes, ma'am. And a question from 2011.
Okay, 2011 question I was not able to find it out.
Ma'am,
Which
question number 28.
28? Question 2011 question number 28, and what is
Yes, ma'am.
other question?
Ma'am, 2022 question number 60.
Okay. Did you find the recording for 2022? Last time I think I told you that this question is already covered. Didn't I?
No, I didn't get that.
Okay. Okay. Regarding the noise thing, right? The question. Which question you are talking about? 2022?
Question number 60.
60. Okay. So you have the reference question, right? So, okay. I'll solve this 2022 question now. So this question is very simple, which you can try and get the answer. Okay, one question which Bunty is asking is r of s plus minus 10. So plus d of s plus. Okay, there. What the question says is, let the error signal e of t is equal to r of t minus y of t. Assuming the difference input r of t is equal to 0 for all t, they are asking what is the steady state error e of infinity due to disturbance d of s. So e of s is nothing but here, because when you take the Laplace transform, even then you'll be getting e of s equal to r of s minus y of s, right? So here this point is e of s. Now we need to compute what is the transfer function e of s by d of s, because they are saying that they are asking the steady state input error due to unit step disturbance d of t. So we need to have this as output and this as input. Okay, so you can follow the signal flow graph. That is, this is the forward loop, like forward path, and this is the forward path. We can, okay. So here they are telling that r of t is equal to 0 for all t. That means that r of s is equal to 0. So you can have it as forward. Yeah. So I'll draw the diagram here. Closed question. 20th question. One second. Let me see the question once. The figure. Okay. Y r of s and y of s is the input. Okay. So when r of s is equal to 0, we have, you can redraw this as, here you have only e of s. This is equal to 0. So anyway, have it as, okay, have it as 0 only. Why 0 means, so see what the question says is, if you have the reference input, there are two inputs which are going into, so this output y of s is impacted both by r of s and d of s. When you see the superimposition principle and all, if you're like trying to find the output due to one of the inputs, you'll make the other input 0. That's what you do in networks or anywhere where you are using the superposition principle. So here they explicitly told that the r of t, the other r of t is 0. So now we can do like this, where we need to find out e of s with respect to the input d of s. Only then you can find out what is the error caused by the input, unit step input that you are giving into the system. So you can either form the signal flow graph and compute the transfer function, or you can go by the conventional way, where from equation 1, from this equation, you have e of s is equal to minus y of s. Since RFS is equal to 0, right? So when you can find y of s, y of s can be written as having, this is 10 times, here the point 10 times e of s. So here 10 times e of s plus d of s, and this gets multiplied with the transfer function which is given here, that is called as y of s. So how can you write y of s? Y of s is equal to 10 times e of s plus d of s into 1 by s into s plus 10. So from here you know what is y of s, because we need to change it to e of s so that we can find the transfer function e of s by d of s. Once you find it, let me tell you that y of s is equal to minus e of s. So minus e of s is equal to 10 into e of s plus d of s into 1 by s into s plus 10. Right? So we know that d of s is equal to 1 by s because the input is unit step input. So minus e of s is equal to 10 into e of s plus 1 by s into 1 by s into s plus 10. So when you're rearranging this and finding out what is e of s, you'll be getting like minus 1 by 10s plus s square plus s plus 10. Just take it to this side and find out what is the error, Laplace transform of error signal. So for us, they are asking what is e of infinity. That means by final value theorem, s tends to 0, the s into e of s. So when you multiply by s, what you'll be getting is minus s by 10s square plus, sorry, you will cancel out one s. No, the denominator comes like this, s plus 10. You can limit s tends to 0. Cancel out one of the s. So you will be getting minus 1 by 10 plus s into s plus 10, where s is equal to 0. So when you're doing that, this goes away. So minus zero point 0.1. The answer should be minus zero point 0.1. Is this clear, Bunty?
Yes, ma'am.
Yeah. So whenever
Ma'am,
they are, yeah, tell.
ma'am, one more question is from 2011, question
Uh,
number 28.
okay, that question, I'll check where it is. Okay, it is based on state space representation. Is it not?
Yes, ma'am.
What they are asking in the question?
Ma'am,
I mean, what is the question? What they are
question,
they are asking about the
ma'am,
continuity
ma'am,
observability.
a block diagram is given and space spread model is, they are asking about, yes, state space model of the above system in terms of vector, state vector x
Okay,
and output vector y.
okay. So which question?
Ma'am, 2011, question number 28.
Okay, I'll just refer it and I'll next Monday I'll let you know. I should first see the question. I don't find the 2011 question paper here. You found it from the internet, right? No.
Yes, ma'am.
Okay, I'll check this once and I'll get back next week.
From IIT Madras.
Oh, it was found by IIT Madras only. Okay,
Yes, ma'am.
okay. I'll see this and let you know. So yeah, it's already 7. So yes, if you have no other doubts, you can exit from the class. Thank you for joining.
Thank you, ma'am.
Thank you for joining.